Hi everyone, today's lesson is on graphing and writing linear equations for geometry students. So let's get started. We'll start with a warm-up, and this chapter is basically on coordinate geometry. So this is a coordinate geometry question. We want to show that the triangle with vertices D, which is 0, 0, so that's going to be 0, 0, E, which is 3, 1, and F, which is -2, 6, so -2, 6, is a right triangle. So for you to prove that this is a right triangle, we're going to draw this first and connect all the vertices. We're trying to prove that that's a right triangle. In doing that, to me, it looks like, this is what it looks like. It may be perpendicular right here. So with that in mind, I'm going to try to show that the slope of this segment and the slope of this segment right here are perpendicular based on perpendicular slopes have a product that equals to -1. So let's find the slope of DE. So the slope of DE, remember the formula for slope, and that's where you subtract your y's over x's. So we're going to say 1 minus 0 over 3 minus 0. And that slope is going to be positive 1/3. And then we're going to find the slope of, let's see here, DF. So the slope of DF. And so we're going to subtract those y's and over those x's. So subtracting our y's, we're going to say 6 minus 0, 6 minus 0, and -2 minus 0, which gives me 6 over -2, which is -3. If these two slopes are perpendicular, and you know they are because they're what we call opposite reciprocals, which basically means that you can multiply these two together, so 1/3 times -3. And if you get -1 as an answer from this product when you're multiplying, then the two lines are perpendicular, which would make this a right angle. Excuse me. So 3 divides into 3 one time. -1 times 1 is -1. -1 equals -1. Check. So you would say, therefore, those 3 dots mean therefore, since the slopes of the two segments, or you could say sides of a triangle, are opposite reciprocals, or since the slopes are perpendicular, the product of the two slopes is -1. Okay, and that's what you would say. It's like a conclusion to your coordinate geometry proof. So forms of equations of line. So there's 3 forms of equations of line that we usually use. Point-slope form is when mostly you are given a point and a slope. So we'll call that point that we're given HK, and you're given a slope. And different books use different letters. Most use M, some use the letter A. An example of that might be this equation. So y minus k is equal to m times x minus h. So this form right here is what we call point-slope form. And if you notice this one thing, if I gave you the point hk, see how it's positive h and positive k? This right here, see the minus sign? That's the opposite, and this is y. This goes with x, this goes with y. And that's the opposite of h. Okay, so something you might use this with is if they give you the point, let's say 2, -3, and I give you a slope of maybe 2, you're gonna write this like this: y, opposite of the y coordinate, so y plus 3 equals, this is where your slope goes, and then x minus 2, because if it's positive here, it'll be negative here. And so this is the equation in point-slope form. Okay. Slope-intercept form is where they give you a slope and an intercept. And the intercept that they give you is your y-intercept. Okay, so they may say, here's your slope is, let's say, 1/2, and your y-intercept, which they do call b, is 5. The equation of my slope, given this equation, so it would be y equals mx plus b, where b is my y-intercept, m is my slope, and so that would be the general form for that equation. So given a slope and intercept, so if these are the values that I have, my equation would be y equals m, which is 1/2, and then x plus 5. And so that would be the equation given a slope of 1/2 and an intercept of 5. The last form is what we call standard form, and that would look like this: ax plus by is equal to c. There are some restrictions with this, and that's where a is a positive integer. And an integer basically means it's not a fraction, it's a whole number. And so a has to be a positive integer. So an equation might look like this: 2x plus 3y is equal to, let's say 12. Okay, so this would be an equation in standard form. Now, the benefit for having an equation in standard form is that you can graph by intercepts. So this allows you to graph by intercepts. And what that means is intercepts. I'll put it as there. If I were to graph this like this, okay, most people, when they're looking at this equation right here, in order to graph it, would actually go, okay, I can't graph that unless I solve for y. So I'm going to come over here. I'm going to show you what I'm talking about. I'm going to solve for y, meaning I would have 3y is equal to negative 2x plus 12. I would divide everything by 3, and I would have a y is equal to negative 2/3 x plus 4. Okay, now if that was the case, then that slope-intercept form, that's super easy to graph. You just go up 4, put a point there, down 2, over 3, down 2, over 3, etc. And so my graph looks like this. Now, that's going from standard form to slope-intercept form. What I'm telling you is that I could graph this by intercepts, and graphing that by intercepts would look something like this. If you're trying to find the x-intercept, you set y equal to 0. So to find the x-intercept, you would set y equal to 0. So if I set y equal to 0, this would be gone, and I would have 2x equals 12, x equals 6. So that means that if I have 2x equals 12, because y is 0, x is equal to 6. So at 6, that's where I have an intercept. So at 6, 0, that's an intercept. Notice that 6, 0, y 0, finding the x-intercept. And then if I were to set x equal to 0, I would have 3y equals 12, and so y equals 4. On the y-axis, I would go up 4. And so what this is 0, 4. And so this is the same line as this. These are exactly the same lines, except for I'm graphing by intercepts instead of graphing by solving for y and doing all these extra steps. You don't have to do that. So point slope form, again, I'm going to give you a point, and x1, y1 just means that's I like to use hk instead of x1, y1, but you're welcome to use that. What I had given you on the previous slide is given the point hk, where m is my slope, you would write y minus k is equal to m times x minus h. And so let's practice one more problem. If I give you the point -1, 7, and I tell you that my slope is equal to, let's say, 1/2, you would say y, that doesn't actually look like 1/2. Let me fix that. Slope is 1/2. You would say y minus 7 is equal to my slope, which is 1/2, times x plus 1. Opposite, opposite. And that would be my equation in what's called point slope form. If I were graphing that, I would go over 1, up 7, notice I don't start on the y-intercept. I go over 1, up 7. And then my slope, which is 1/2, means going up 1 over 2. So my graph would look like this. Slope-intercept form, you're just given a slope and an intercept. So if I said that my slope was -7 and my y-intercept is, let's say, 2, my graph would start at 2, and then it would, slope is rise over run, so down 7 over 1. Keep in mind that when you are graphing, if you notice that your slope is negative, it does have to go down to the right. Standard form for this right here, for standard form, this just tells you that you're graphing by intercepts. Again, if you want to find the x-intercept, you're going to set y is equal to 0. If you want to find the y-intercept, you set x equal to 0. So, and what that means is, again, I could just show you, let's see, if I said, started with, let's say, 2x minus 5y is equal to 10. And I wanted to graph this rather quickly instead of solving for y, which I could do, but I would set x equal to 0 to find my y-intercept, meaning I would go 2 times 0, which is 0, minus 5y is equal to 10, and I would divide both sides by -5, and I would get y is equal to -2. So on my y-axis, I would start my graph down here at -2. To find the x-intercept, I set y equal to 0. That's gone then. And so now I have 2x is equal to 10, so x equals 5. So 2, 3, 4, 5, this graph point goes there, and then there's my equation on my line. All right. So we're going to create an equation given we have a y-intercept of -2 and a slope of -4. So the y-intercept, that's my b, which is -2, and my slope is equal to -4. So slope, you're going to say y equals mx plus b. So mx plus b, because they gave me an intercept and a slope. So y is equal to m, which is -4x minus 2. So here's the equation of the line, and I want to graph that, which means I'm going to start at -2, and then I'm going to drop down 4, 2, 3, 4 over 1. See the 1 underneath the 4? There's always a value under there. Keep in mind this is a negative slope, so it does go down like that. Okay. I would move this to the other side. Let's say this is in slope-intercept form. If I asked you to put this in standard form, which, remember, standard form was ax plus by equals c, what you should notice about this form is that the a and the x and the y are on the same side. So I'm going to take this -4 and move it over to the left. And in doing that, bringing it over to the left, I get positive 4x plus y is -2. And so what this is in standard form. Okay, and that's just another option for you to graph, to write the equation. X and y are on the same side, and remember, for standard form, the 4 does need to be a positive integer. Okay, this one, number 2, is asking me to come up with an equation where the line goes through this point. So they gave me a point, which is 1, -2, and a slope of -3. So that means over 1, down 2, and now I have a slope of -3, so down 3 over 1. So this graph is going to also drop down, but at not the same, they are going to intersect, because unless the slopes are the same, see how this slope is -4 and this slope is -3, they're not going to be parallel. Okay, so let's come up with the equation. So we subtract our y's. So this is y minus -2, which makes plus, is equal to my slope, which is -3. And then I have x minus 1. Now this equation is in what we call point-slope form. I would ask you to take that equation in point-slope form and transfer it to slope-intercept form. And remember, slope-intercept form, this one right here, is where you solve for y. In slope-intercept form, you solve for y. Okay, and so we're going to get y, we're going to isolate the y. So we're going to get y equals, I'm going to move this 2 to the other side. And in doing that, it's going to be a negative 2 over here. See how it's positive 2 right here? When I move it to the other side, it's minus 2. And for this, I'm going to distribute. See this negative 3? I've got to multiply it by both terms. So it's going to be y equals negative 3x plus 3 minus 2. So I have y equals negative 3x plus 1. And that's what we call slope-intercept form. Okay. And then once we have it in slope-intercept form, I would ask you to do one more step and put it in standard form. And then I would take this 3x and move it to the other side. And now I have positive 3x plus y is equal to 1. And now we're finally in what we call standard form. Not every question needs to be in standard form, but you do need to know how to get it to that point. The next question says, write an equation of the line, graph the line. So we have over negative 2, 3, 4, up 5. So 1, 2, 3, 4, 5. So here's the point, negative 4, 5. And then we have the point 0, negative 3, which is here. So 0, negative 3. So actually I have options for this problem. Number one, because I have a y-intercept, see that? And so given that, I could even put it in y equals mx plus b form. Y equals m, my slope, I can just count if I wanted to. Let's do that. So if I went up 5, that means, and then down 3, that means I dropped down 8, so negative 8. And moving over, if it was at negative 4 and I'm moving over here, then that means that's a 4, right? So my rise is a negative positive. So that's going to be negative 8 over 4, which is negative 2. So my slope is actually negative 2. So y equals negative 2x minus 3, because negative 3 is my b. That's my y-intercept. So this is the equation in slope-intercept form. But I want to show you another option, okay? Because most of the time when they give you a point, they don't give you the y-intercept. They give you a point, and then you can find the slope between the 2 points. Remember the slope formula that says the change in y over the change in x basically says subtract your y's. So we're going to go negative 3 minus 5, that one, subtracting my y's. And then I go 0 minus negative 4, which makes plus 4. So I get negative 8 over 4, which is negative 2, which we knew our slope was negative 2. Once you have that, let's see, I'm actually going to, move this, because I am going to put that in standard form. So once you have your slope, you're going to choose a point. You're going to pick which point you want to use. I'm going to choose this point to start with, and then show you this point as well. So this, I'm going to put this in point slope form, okay? Because most of the time, if they give you a point or 2 points, you can put it in point slope form. So we have y minus 5 is equal to, remember, this is with x, this is with y. So y minus 5 equals negative 2 times x plus 4, point slope form. Then to put it, if my goal is to put this in standard form, then first, the next thing I need to do is put it in slope-intercept form, which means I need to solve for y. So now I'm going to solve for y, and I get y equals, I'm going to distribute at the same time. I get negative 2x minus 8. And see this negative 5, I'm bringing that over to the other side, so now it's plus 5. So I have y is equal to negative 2x minus 3. So now I'm in what's called slope-intercept form, SI form. And so that solved for y. And again, down 3, go down 2 over 1. It's the same line, okay? Just a different place to start, where before we started at the point they gave us. Now I'm starting at the intercept. To put it in standard form, all I have to do is to take this negative 2x and move it to the other side. So now it's positive 2x plus y is equal to negative 3. Okay? So this is just a couple of coordinate geometry questions that we have started, if you're trying to find the perpendicular bisector of something, basically how do I bisect this segment? To find the bisector of this segment, first you would need to find the midpoint, okay, which we would use the midpoint formula. And the second thing you would need to do is you would need to know if the slopes are perpendicular, because not only do you have to be able to prove that those two sides are congruent, but you also need a perpendicular line through there. Excuse me. So like we did in the example, we would use the opposite reciprocal of the slope, meaning the product is going to be -1. We would use the midpoint formula to find this value, and then we would take our equation and put it in point-slope form. Now, a median, if you recall from geometry earlier when we were doing constructions, to find the median, you would bisect this length. Remember, we would arc up, arc down, draw our line that, oops, that was a little bit too close there. Draw our line that bisected this segment like that. And then it was a perpendicular bisector, but the actual median goes from the vertex to the midpoint. So that line right here is the median, not this bisector. So you would definitely need to find the midpoint in order to find this point, but also you'd use point-slope form. Altitudes, lastly, altitudes always are perpendicular. They come straight down. And so you want it in point-slope form, but you're looking for this perpendicular line. So again, you're looking for that the product multiplies to be -1. Oh, those are just examples of what these are. This is an altitude. This is a median. And this is a perpendicular bisector. So write the equation of the line that's a perpendicular bisector of segment AB. So given that A is -5, 1, 2, 3, 4, 5, -5, 1, 2, 3, 4. So here's A. A is at -5, 4, and B is at 3, 0. So 1, 2, 3, 1, 2, 3, 0. So here's B. Okay. And your job is to find the equation of the line that's the perpendicular bisector of that segment. Meaning what I'm looking for is first to bisect that segment, right? So I need the midpoint. So at first I'm going to look for the midpoint. And secondly, I'm going to look for the slope that is, okay? So first, let's find the midpoint. To find the midpoint of AB, okay, the midpoint, we're going to go, to find the midpoint, it's the average of the x's divided by, add the x's, divide by 2, so it's the average. So we're going to go -5 plus 3, divide that by 2, and 4 plus 0, divide that by 2. So we get what is that? -2 divided by 2 is -1. 4 divided by 2 is 2. So it looks like at -1 up 2, so at -1, 2, that's my midpoint. But keep in mind, now what I have here is the midpoint is a point on my new line. So basically, I could actually start writing my new equation given this point, -1, 2. So I would go y minus 2 equals my slope, which I don't have, times x plus 1. But so far, that's what I have. So now to find the slope. Now, what you do need to know is that if it's perpendicular, this is the key word, then my slope is going to be the opposite reciprocal. So what I need to do is to find the slope of AB. I need that slope. So I'm going to subtract my y's over subtract my x's. So I'm going to go 4 minus 0 over -5 minus 3. So 4 minus 0 is 4. -5 minus 3 is -8. So it looks like the slope for line AB is -1/2. So the slope of AB is equal to -1/2. Now, if I was looking for, let's say, the slope of the line that's parallel, that would also be -1/2. But I'm looking for the slope of the line that's perpendicular. And that is the opposite reciprocal. So if it's negative, it's positive. If it's 1/2, it's flipped over. So now my slope is 2. So that's what's going to go right there. So we're going to say y minus 2 equals this 2. times x plus 1. And then that's point-slope form. And if I want to put that in standard form, you just have to work it out. So solve for y first. So you have to go to slope-intercept form next, meaning solve for y. So 2x, 2 times 1 is plus 2. And see this negative 2 right here? That has to go over to the other side. So that's a plus 2. So now I have y equals 2x plus 4. Now this is what we call slope-intercept form. And now to put this in standard form, remember standard form, ax plus by equals c, where a is a positive integer, meaning it's a whole number. So first I need to move this to the other side, and I get negative 2x plus y equals 4. But this is not in standard form. So for this to be in standard form, I would need to multiply the entire equation by negative 1. Keep in mind, you just can't change the sign. And the reason that you can't do that is because it is an equation, meaning whatever you do to one side, you have to. So we're going to go negative 1 times negative 2x is 2x. Negative 1 times y is negative y. And negative 1 times 4 is equal to negative 4. And so this is my equation in standard form. Okay? And we just did that. And that's it. So I hope that helped you graphing and writing linear equations. So thanks for watching.